Hello everybody, I'm Brandon, and right now I'll be showing you how to solve problem number 15 on chapter 6 for Physics B AP. Problem number 15 reads, the front 1.20 meters of a 1400 kilogram car is designed as a crumple zone that collapses to absorb the shock of a collision. If a car traveling 25 meters per second stops uniformly in 1.20 meters, A. How long does the collision last? B. What is the magnitude of the average force of the car? And C. What is the acceleration of the car? Express the acceleration as a multiple of the acceleration of gravity. So three-part question. It will involve kinematics as well as the equation for momentum. So let's get started. Alright, so here's my beautiful picture of the car. We know that that's 1400 kilograms. The front 1.20 meters is the crumple zone. It's moving in the positive x direction at 25 meters per second. And my coordinate system is plus y going up and plus x going to the right. To solve part A, which is asking for the time, we need a kinematic that doesn't include acceleration because we are not given acceleration. That kinematic is then delta x equals half velocity initial plus velocity final delta t. We know that it stops in 1.20 meters. We know that the velocity initial is 25 meters per second. If it stops, then we know the velocity final is 0 meters per second. And then delta t. So solving for this means that delta t equals 0.096 seconds. And that is the first part of number 15. And we used a kinematic, it was very easy to get to that number. So part B is asking for the magnitude of the average force on the car. They want their answer in newtons because that is the force. This problem has different steps. First, what we need to do is we need to solve for impulse, and I'll write the equation right now. Impulse equals delta momentum. And then we're also going to need the equation momentum equals force delta t. And how we're going to use these is we're going to solve for the delta momentum, and then that is going to equal our force delta t. We found our delta t, and then from there we can get our force. So delta momentum equals the mass velocity initial minus the mass velocity final. Equals mass is 1400 kilograms. The velocity initial is 25 meters per second. And then minus the mass again is 1400 kilograms. And then the velocity final is 0 meters per second. In which case, that part cancels out because 0 times anything is 0. 1400 kilograms times 25 meters per second means that our momentum, or actually our delta momentum, is 35000 kilograms times meters over second. So 35,000 kilograms times meters over second. That is our momentum, but we're not done here because we're not trying to find momentum. We are trying to find force. However, now that we have momentum, we can find the force by dividing that number by the time. So 35,000 kilogrammeters per second equals force, we're trying to find out, But delta t we got in the last one. That's 0.096 seconds. I'm going to make that s smaller so we don't mistake it for 5 seconds. And then force equals 3.65 times 10 to the 5th power newtons. Whoops, you can't see that. There we go. So, to review, what we did was we found the delta momentum. From there, we solved for the force using the time that we got in Part A. Part C wants the acceleration. Wants the acceleration of the car. And to do this, we have to use another kinematic. I'm going to use the one. Velocity final equals velocity initial plus A delta t. And the reason I'm using this one is because they gave us the velocity final, or we can assume that the velocity final is 0 because it is brought to rest after it collides. Velocity initial they gave us, acceleration we're trying to find, and delta t, again, we found in the first problem. So doing this, velocity final is 0 meters per second equals velocity initial 25 meters per second plus acceleration times 0.096 seconds. Doing that will give you 260.41 meters per second squared. That technically is the acceleration, but the book wants to make us go that extra mile, and they wanted acceleration as a multiple of the acceleration of gravity. So how you do that is you take this number and divide it by 9.8 meters per second squared, because that is the acceleration of gravity. Then you get 26.6 g. 260.41 divided by 9.8 meters per second squared is 26.6 times gravity, or 9.8 meters per second squared. That is your final answer for Part C. So I hope this helped you out, and good luck on the test.